Now we're going to look at the rules in PD for dealing with the existential quantifier. So, same as with the universal quantifier, there's one that's fairly simple and then one that's more complicated. The fairly simple one is existential introduction. So, the way that it works is if you have a sentence that contains a constant, then you can replace the constant with variable and put an existential quantifier in front. The inference here is that if you have a sentence that is about some particular thing, right, it's true of some particular thing, then it is true of something. So if Susan is eating a hamburger, then something is eating a hamburger. If Justin Trudeau is Prime Minister of Canada, then someone is Prime Minister of Canada. And Justin Trudeau is Prime Minister of somewhere, and someone is Prime Minister of somewhere. These are all true. Okay, so here's an example of how this works. Um, I am not exactly the most athletic person, right? There are not many things that I can run faster than, but I can definitely run faster than turtles. So this argument will show that if there's some particular turtle that I can run faster than, then I can run faster than something. So here are the premises in PL. Now, step one, we use universal elimination to take this universal claim and make it specifically about Max, right? If Max is a turtle, then I can run faster than Max. We then apply conditional elimination to get the result that I can run faster than Max. And then we use the existential introduction to get the result that there is a Z such that I can run faster than Z, right? I can run faster than something. Um, Now, if you remember from when we talked about universal elimination, right? When you performed universal elimination, you had to take every occurrence of the variable in the sentence and replace it with a constant, the same constant, in fact. And if you didn't do this, then the result wouldn't be a sentence because you would have variables left over that were not governed by any quantifier that told you how to interpret them. Um, yeah, this doesn't apply to existential introduction. So here, for example, if you have the sentence LAA, then by existential introduction, what you can get is you can replace both of the constants with variables, or you can just replace one of them. All three of these are fine. Okay. For the next rule, um, suppose you're a detective who's investigating a murder. So the victim's body is found in the parlor, and one of the windows of the parlor was smashed from the outside. And then in the garden, there are footsteps going through the garden that lead up to the window. So looking at this evidence, then what you conclude is, well, the murderer probably came in through the window. Now, there's a subtle logical move that is being made in this conclusion that really, I mean, when we do this, we're almost never aware of the fact that we're doing this. And this is that given that we're aware that somebody murdered the butler, we are introducing a term for that somebody, which is the murderer, right? This is a term that we're introducing for the person who committed the murder. Um, And this is actually an important move because by introducing this term, we can refer to this person. And because of the fact that we can refer to this person, we can integrate different lines of evidence more easily, et cetera, et cetera. Um, this is, if you remember, like way back when we were first talking about the elements of language that PL talks about, we talked about definite descriptions. This is a definite description, right? It is a description that denotes a single object in the universe of discourse. We hope. I mean, presumably, given the evidence that we're looking at, there was somebody who murdered the person, and there was only one of them. So we're expecting, fallibly that this is a definite description. Definite descriptions function logically like names, right? They are unique identifiers, right? They denote single objects in the universe of discourse. Um, and actually, in a situation like this, you could have just made up a name for the person who committed the murder instead of using a definite description. In the movie L.A. Confidential, Ed Exley does this, right? So his father was murdered by some unknown person, and what he does is he coins the name Rollo Tomasi for this unknown person. Now, so yeah, uh, there are two things that are important for this particular logical move to be truth preserving. First of all, whatever term you use, whether it's a name or a definite description, it can't already belong to anything in the universe of discourse. So if Ed Exley is going to introduce a name for the unknown person who murdered his father, he can't decide he's going to call his father's killer Lester B. Pearson because that name already belongs to somebody. We can call the person who murdered the butler the murderer because that is a very generic term. We couldn't go and call it the butler's wife because this is just going to lead us to make false inferences. Another thing is that you can't you have to make sure that you're not drawing inferences that are based on the names you choose, right? You can use these names to help you keep track of various lines of evidence and things like that. But you want to make sure that you're not drawing inferences specifically from them, right? So if Ed Exley is going to name the murderer of his father Rollo Tomasi, he can't then go back and look at it and say, well, if the guy's got the last name Tomasi, he's probably Italian. This again just going to lead to false inferences. So this move here, right, the one that we're not normally aware of making, that's existential elimination, or that's the basis for the existential elimination rule in PD. So the rule looks like this. You start off, you have a sentence, an existentially quantified sentence. Then what you can do is you can start a new subderivation. And in this subderivation, you strip off the quantifier, you replace the variable with a constant. This constant is standing in for the object that satisfies this formula here. So you're basically you're introducing a subderivation where you suppose that this is the object that makes this existential claim true. And to make sure that this is that you don't have like it's a new name, right? It doesn't have any, there's no information that you already have about this. Then you have these two provisos that you have to satisfy. It can't occur in any open assumptions, right? So you can't have any information specifically about that constant, and it can't occur in the existentially quantified sentence. In which case, because then too, right, you would have information specifically about it. Then you go through this subderivation, and if you reach a sentence that does not contain that constant, so it's not specifically about that object that you're supposing is this thing. It doesn't contain that constant anywhere. It's something more general than that. Then you can infer this in the main derivation. You can't infer a sentence that contains this constant that you introduced because that wouldn't be truth preserving, right? You don't know that this constant is actually the thing that makes this true. You don't know that that constant actually satisfies this formula at all. You're just supposing it in this subderivation. But if you can draw a conclusion based on that doesn't involve that constant, then it's truth preserving. Then you know that that is going to have to be true. So then you can infer that. Okay, so we'll look at an example. We'll take that classic argument about Socrates being mortal and we'll just generalize it. So now it's all men are mortal. There is a man, will remain neutral on whether that's Socrates or not. And then the conclusion is just something is mortal. So here are our premises in PL. We're going to derive this sentence here. Step one, we will use existential elimination. We'll just introduce a constant A. We could have used any other one because there are no constants in our assumptions here, so any of them would have been fine. When we cite this, we cite it as an assumption for existential elimination, because of course we don't know that A is human. We're just assuming that for the sake of this subderivation. Then we can use universal elimination on this. Note that we could have actually done that before the existential elimination step, and then A still wouldn't be in an open assumption, so it would still be fine to do the existential elimination after that. We'll use conditional elimination to get MA, so we've deduced that A has to be mortal. We could not pull this out of the subderivation because it is still about A, right? And again, we don't actually know that A is human. We were just supposing that in the subderivation. But if we do existential introduction on it and just get the result that there is an X such that X is mortal, then we can use existential elimination to pull that out of the subderivation. And that's our conclusion here. And the way that we cite this then is you cite the line that the existential claim's on, and then you cite the subderivation. And that's how existential elimination works. Now, one question is this: why exactly do you need this subderivation? Because the way that I've been talking about it is that the reason is that what you're doing in the subderivation is you're supposing that this constant is the thing that makes that true. And that is a good way to thinking about what you're doing there. It's not strictly speaking why you actually make that subderivation. The actual reason why you do it is this: if you want a natural deduction system to be truth preserving, you have to block this inference here, right? Like you have to make sure that it is never possible for somebody to make this inference. Where you start with an existential claim, right? Like there is an XFX. Then you do existential elimination on it to get FA, right? And then from the FA, you go with universal introduction and get for all XFX, right? This is clearly not truth preserving because you'd be able to start with any existential claim at all and end with having converted the existential into a universal. And this is just, I mean, this is not a valid inference, right? So if you want your natural deduction system to work, you have to block this from being possible. So this is how PD blocks this. The way that you block it is you start off with this assumption, right? Some existential claim. Then at the existential elimination step, what you do is you introduce the subderivation. Now, because of the fact that you have A in an open assumption, you can't use universal introduction on it. So anywhere inside the subderivation, you can't use universal introduction on A. So right there, the universal introduction thing is blocked. If you're really determined to use a universal introduction, the other possibility would be to try to pull A out, like some, FA out of the subderivation, and then do it in the main derivation, but you actually can't do that either because of the last of the provisos for existential elimination. It says that any sentence that contains A cannot actually be inferred out of that subderivation, right? They have to remain inside the subderivation where you can't use universal introduction. So that's the sort of the formal technical reason for why you have that subderivation is it makes the system truth preserving by blocking that invalid inference from being possible. And every natural deduction system for predicate logic has some way of doing this, but this is a particularly nice, elegant way of working it out so that you don't have like, weird sort of provisos that are hard to keep track of and stuff like that. The subderivation way of doing it is just it's a nice, elegant way of doing it. So those are the rules in PD for dealing with existential quantifiers.